Welcome back, everyone, to the third part of the 8-part Chainlink Educate series. Today, we are very lucky to be joined by Richard, who is a developer advocate at Chainlink Labs for the topic of VRF today. Of course, as usual, if you do have any questions that come up throughout the presentation, be sure to throw those in chat and we'll be sure to get those answered for you. I'll be throwing a few links in here just regarding the Discord channel, as well as the summaries for the past 2 events, just in case you missed those, as well as the registration link for the next event that's coming up on the 5th of July. Richard, feel free to take over.
Yeah, thank you very much. So I'm Richard, one of the developer advocates for Chainlink Labs. And yeah, they asked me to give like a random talk, I guess, but randomness. That's what VRF does. It's verifiable randomness function is what VRF stands for. So we will be talking about that today, as well as going through a couple of demos. So I guess I'll get started. I'll try my best to keep an eye on the chat to answer questions. And yeah, let me share my screen and let's get going. Yeah, I am Richard. There's my Twitter and email if you'd like to reach out to me afterwards. Have any questions? I love chatting with people. The DMs are open on Twitter. I will have links to this as well later on that I'll share. But I believe everyone has a little bit of familiarity with Chainlink and smart contracts, obviously. Talking about what Chainlink is. It's a distributed Oracle network that essentially allows you to solve the Oracle problem, which is the problem of bringing off-chain non-deterministic data on-chain. And I'm going to ask everyone a very hard question here. I'm curious, like Danny, Eva, Steve, if you can answer this question with me. If I were to ask you, what is 1 + 1? Can you tell me?
I have to go with 2.
It's 2, right? Yeah, okay. We all agree it's 2. Fantastic. That's deterministic value. We'll all agree it's 2. Now, if I ask you the same question or same type of question, what's the temperature outside right now in Fahrenheit? I'm going to say it's like 98 degrees. Everybody agree? No, it depends, right? So those are non-deterministic values. Anytime you have an answer to a question of it depends, that's non-deterministic. That's kind of what the Oracle problem is. It's bringing non-deterministic value on chain because blockchains need you to have every node within the blockchain agree to the answer and value something. They need to reach consensus. When we said 1 + 1, we can all agree it is 2. When I ask what's the temperature outside, like make an API call, like what's the temperature, we don't all necessarily agree because it depends on when and where we're talking about. This is a very important concept to understand too, because if I were to ask anybody in the chat to give me a random number, obviously you all thought of 4,732, right? No, randomness is not deterministic either. And so we have that same problem. That's where Chainlink VRF comes in and provides a random value on chain. When we think about oracles, we could have a single server that does this. We could have a Oracle node that provides our smart contract with a random number. And I could set that up, right? I could have one sitting here in my office and do that. Except for we have one node, it's centralized. If it goes down, we run into the problem of like, hey, we have this blockchain that's distributed. All of this awesome power of the blockchain fails because we have one node. We run into that problem if we don't have a distributed network of nodes. So again, this is just kind of recap real quick of Chainlink nodes. In this image here, we're talking about pricing, but instead of prices, imagine random number, reaching consensus on a random number and providing that to a smart contract is one of the capabilities of the Chainlink Oracle network. We have data feeds, which I believe you've talked about already. We have VRF, which is that randomness function. Then we have keepers, which allows you to automate contracts. But again, today, we're just talking about, I'm going to take a look at VRF. So VRF lets you get randomness into your blockchain applications in a secure and verifiably random fashion. Now, we can get to kind of the more interesting part of like, what do we mean by verifiable randomness? Within the blockchain space, random numbers are often created by using something like a hashing algorithm to generate a numeric hash. And you could do this and accomplish this fairly easily in a smart contract if you took a input like the block hash and then hash that to generate a random number, or the user's wallet address and hash that and generate a random number. And that would give you a random number, sort of. The wallet address is maybe not going to give you a actually random number, because anytime you hash that, you're going to get the same result. If you took like the block hash and used that, that wouldn't be necessarily able to predetermine what the result was. But there's a problem there in that when a miner, the person who actually mines that bit of information into the block, when they know how a random number is generated, they can kind of look into the future, if you will, and see what the result would be, and then decide if they want to include that transaction or not in the block. So it's kind of like saying, I have a D6 dice and I'm going to roll it. And I'm only going to record when it rolls a 6. So I can't record, like, I can't determine the results of that roll, but I can keep rolling until I get the result I want, and then say, see, I rolled a 6. So that kind of manipulation of randomness is a possibility when you are generating random numbers actually on the blockchain. So that's where Chainlink VRF comes in. We have that node network that's outside of the blockchain that will generate a random number along with the proof of randomness, and then submit that value to the blockchain. And I'm going to pause for just a moment. I don't know if I can get the chat to show up. I can. Cool. I'll pause for just a second and see, are there any questions so far? Give you all a moment. If you want to type in the chat, if you want to raise a hand, ask a question, that's cool too. Okay, I'll keep an eye on the chat and we'll see if there's any questions. But that's ability to generate a random number in a fashion that's not manipulatable is basically like the key important thing when it comes to creating truly random numbers. Now, why do random numbers matter? If you were going to be running a lottery, for example, and there was millions of dollars on the line in this lottery, making sure that the winner of that lottery is random is very important. The same thing goes when it comes to NFTs and traits. Some traits are more valuable than others. And so ensuring that the traits are truly random is also hugely important. In the example that we'll look at a little bit later on, we'll make an NFT and we'll have the color of the NFT be created by this random number generation. So Pool Together and Aavegotchi are just two examples. If you're familiar with them that use VRF, Pool Together, if you haven't heard of it, it's kind of a cool idea. It's a lossless lottery where people put money in. The interest essentially off of that money is what you win if you win the lottery. And if you didn't win, you get your initial amount of money back to you. Like, that's pretty cool. And then Aavegotchi is an NFT project where they use randomness to generate the random traits. So I think presentations are great, but I think that looking at actual examples and code is more interesting. So I'd like to dig into that. I have a bit.ly link here. It's just bit.ly/talklinks. That'll take you to a GitHub repository. And you can see the date and the name of this demo in there. And we will go from that, but we will be making a couple of different demos. First, we'll look at the documentation, and we'll make a contract straight from the documentation that will just kind of show us how VRF works and walk through the different steps of creating a VRF subscription, getting a random number, and looking at that random number within a contract. And then we'll take a look at a little bit more involved contract that will actually create an NFT. That's a dynamic NFT. So we'll mint an NFT, and then based on randomness, we'll change that NFT's state and the image associated with it. So again, before we dive into that, any questions at all? This is kind of a look at what we'll be doing here, but the color of the different stages of this flower that goes from seed to sprout to blossoms will be determined by that random value. It's kind of the final project of where we're going, right? I must be the world's best presenter because everything is 100% crystal clear and there's no questions at all. Like I'm feeling good about myself right now. I'm super humble too, y'all. So if you follow that link, you should be here. This is this presentation. If you want to look at other presentations, other examples, they're in here too. But if we head to this presentation here, you can kind of see the links to the things that we'll be using today. We have the documentation. I'm not really going to talk about Pinata except for very briefly. Pinata is kind of an on-ramp for IPFS, which is a distributed file hosting system. It's an interplanetary file system. We have the faucet to get some testnet ETH and link. Remix, which if you're not familiar with it, is a IDE based in the browser for doing Solidity development. The VRF subscription interface to create a subscription for that verifiable randomness. And we'll also be using the Testnet's OpenSea, I guess OpenSea's testnet version, so we can actually look at our NFTs in OpenSea on the testnet. And then here's some additional links to Chainlink's Discord, our documentation, starter kits, Chainlink Academy, as well as my Twitter. Cool. I will try to go kind of slow-ish if you'd like to play along. If you want to go to this link, follow some of these examples with me, you can absolutely do that. You will need MetaMask as well. And we'll need some testnet ETH and link. So I guess the first thing to do is to go to faucets.chain.link. Mine's already on Rinkeby because I'm going to be using the Rinkeby test network. But if you leave that bit off, it'll automatically direct you to the right place based upon your wallet and what network your wallet's connected to. So see here, it'll pre-fill your wallet. Once you connect your wallet, you can get some testnet link as well as ETH. You'll need to prove that you're a human, and then you can get some of that testnet stuff. So if you don't have that already, do that. Rinkeby is a pretty good place right now to run all these tests because all of the Chainlink products there, OpenSea is there, like everybody's there. So the first thing we'll do, oops, I thought I was at the main docs page. If you head to docs.chain.link, that'll take you to the Chainlink documentation. And it has a ton of information here. You can learn about the data feeds, any API keepers, but we're going to be looking at VRF randomness. And it's kind of split into two different sections here. We have Solana, because Solana is a completely different animal when it comes to how things are done there. And then we have the EVM chains, which are going to be mostly based around like Solidity and Ethereum style coding. So if we go to randomness in the documentation, it will give you an overview of how VRF works, what VRF is. One very important thing to point out, not too long ago, we transitioned from VRF v1 to VRF v2. There's a lot of cool stuff that came along with that transition. The first is you can get like multiple random numbers in one request, which is awesome. You can create a subscription, which is essentially you create a bucket of link and then you give access to various contracts to that bucket of link to call and make those calls for random numbers, which we'll take a look at how to do that here in just a moment. But that is really, really handy, I think, because then you don't have to fund each individual contract in order to get VRF enabled in that contract. And the way that the two functions that you'll need to both request and fulfill randomness are slightly different between 1 and 2. There's a transition guide, but just keep that in mind. If you've used this in the past, V2, highly, highly recommend moving over to it at some point in the future. I don't know when. V1 will have to go away. So just keep that in mind. But VRF v2 is really good. We will take a look at getting a random number. You can watch like an explainer here. It tells you the different networks that we're on currently. We're always adding new networks. And it talks you through subscription and the billing and how gas prices are calculated. If you want to dig into all of this technical information, feel free to, but I am concerned more with getting a random number. I want to get that random number. So the first thing that we'll need to do is we'll need to create and fund a subscription. So again, all these links are here in this GitHub repository. We're going to the VRF subscriptions link now. So it's going to be vrf.chain.link. And from here, you will need to connect your wallet. And again, I always like to caution people, make sure you're on a testnet before you do anything. Because if you're not on a testnet and you click that confirm button, like you spent real ETH, make sure you're on a testnet. We're going to create a subscription. It will populate the subscription address. That's your wallet address. Click that create a subscription. And this will, zoom window in the way. This will give you a confirmation through MetaMask or your wallet to create that actual subscription. We'll give it just a moment. And then you can add funds if you want. So this is where you'd add that link. Link is essentially the native token of the Chainlink Oracle network. It lets you do a few things with it where you can transfer it to a node with a request, like you can do what's called transfer and call. You can transfer it with like the request that you want to make, right? So in this instance, we'll be doing that with our VRF requests. I'm just going to put a little bit of link in there. 10 is probably way more than we would need for this. Like 5 would be plenty. I think the faucet gives you 20, or was it 10? No, it's 20. Yeah, so if you want to do 10, follow right along. It'll be plenty for this example. We'll need to approve that transfer. We'll wait for that to complete. Contract is not upgradable. How am I supposed to update it to the next version of VRF? That's a good question, Carlos. We have in the migration guide some guidance there on that. If it's not upgradable, though, that's going to be difficult. Yes, because this is like one of the, I don't know if downsides is the right word here. It's one of the limitations of blockchains because we have the immutability of contracts being a thing which has benefits and also costs, as you know, non-upgradability is a problem. Thank you for your question. So after you've added funds to your subscription, you can add consumers. Now, the way that the subscription works is when you deploy a contract for VRF, it's going to need to know about this subscription. And then this subscription is going to need to know about the contract. So they both kind of have to know about each other. We don't have a contract yet though, right? So we'll do this part later. So it's that easy. Well, it's a nice clean ID. At this point, we have created a subscription and we have our subscription ID here. We'll need this in just a moment because this is how we'll let our contract know about our subscription. So let's take a look back at the documentation. We've gone through here. We've created and funded our subscription. We haven't added a consumer yet though, right? This is kind of where we left off because we don't have one yet. So we'll need to create a consumer. We'll need to create a contract to request randomness via that subscription. If you scroll down just a little bit, you can see here, we've got this consumer.sol link to open in Remix. Just click on this link. It should pop Remix open for you. And just to make sure, Danny or someone, is this readable size or should I make the text bigger?
On my end, it's pretty readable, but I would probably recommend making it just a little bit bigger. Just
Okay.
so everyone can see it.
Cool.
Yeah, it's fine. It's fine. I can read it.
Okay, thank you. So this is the sample contract, and let's walk through it real quick and just chat about what all is in here. So we've got the basics setups of Solidity, right? Telling it what version of compiler we need. We're importing a couple of things. These are two different contracts. One's that coordinator, which will allow us to request the randomness. And the other one is a contract that's the base consumer contract, which will give us the ability to like receive back that response. A lot of times, in my mind, I come from like a web development world, and I think about a lot of things that happen in blockchain as kind of asynchronous functions, where you make a request, And then you're going to need some way for that request to come back, except for we don't really have the idea of a wait in Solidity. So we're going to need a function that can be called with that response. That's what the consumer is giving us the ability to do. So we've got a couple of variables here that we're setting. The subscription ID, that's going to be that number from the subscription that we created. We have the address of the VRF coordinator. This is essentially a contract on the blockchain that will coordinate these requests for randomness. This value will change depending on what network you're deploying on. You can see the different ones here at this link. This is for Rinkeby. So the documentation is set up for Rinkeby as the example. We also have a gas lane, which will allow us to configure gas prices based upon the network. We have our callback gas limits. So this is setting like a top threshold of the gas for that callback. Why this is important is when you get those random numbers back, you're going to want to do something with them normally, and that's going to cost gas. You'll see this a little more clearly in the next example with the NFT. We have some confirmations. This is how many like block confirmations need to pass for the random number. The default's 3 for Rinkeby. There's a couple different networks. The Arbitrum, I believe, is one of them, where you can set this down to 1, so you get your random number back much quicker. But essentially, this is going to say that 3 blocks have to be mined before we get our actual response. It's kind of a security, ensuring that the random number is good and actually truly random. We have this value num words. So this will actually allow you to pick how many random numbers you want each request to generate. Words is the reason it says number of words instead of number of random numbers is like the technically correct computer science term for the value we're getting back is a word. If you are really interested, hit me up on Twitter and I will give you a link to an article explaining this, but like we're getting like really down in the computer science weeds here. But this is essentially when you see number of words, just think number of random numbers. So this request will generate 2 random numbers. We have an array to store those when they come back, and we have the request ID. So every time we request randomness, we'll get an ID back for that. You'll see why that's important in the second example as well. Then we have the owner of the contract. In our constructor, we set up the coordinator and the owner and the subscription ID. We also have the next function is that request random words. So this is actually the function that will go to the VRF coordinator and request that randomness. It's going to pass in a few things, that key hash, the subscription, number of combinations, basically all of those settings that we set just above. And so at this point, when we run this function, it'll go off to the coordinator and off into the Oracle network. And then from there, we're going to wait for it to come back. When the random words in those 3 blocks have passed, it's going to then come back to our contract and call this fulfill random words function within our contract. So in this case, all that does is just going to store the random words in this variable. And that's it. That's the whole contract. So if you're following along, you can find this in the documentation. And if you're in Remix, I always forget that I have this auto compile button checked. If not, you'll need to compile this just to make sure you get that green check mark. And then we can deploy this to the actual test network. We'll need to make sure that we pick injected Web3. That's going to take our wallet and inject that information into our browser. So this account here should be the same as your wallet account. We'll need to make sure that we pick the correct contract here. Those other 2 are the ones that were imported. So we're going to be deploying VRF v2 consumer. And in this deploy, it's asking us for our subscription ID. So we'll need to go back to our subscription and grab the ID. Now yours is going to be different than mine if you're following along. So I'll grab the ID here, head back to Remix, put it in, and deploy. And then I'll need to confirm. Now we'll wait for this to actually be deployed. So we've deployed our contract and we've told it about our subscription. Now we need to go to the subscription and authorize this contract that we just deployed to use that subscription. So copy our contract address. We'll head back to VRF subscriptions and we will add a consumer and we'll paste in the address and we'll hit add consumer. And one thing before I confirm this, at this point, if I were to request random words, we're going to see this gas estimation error. So if this pops up when you're using VRF, just think to yourself, did I authorize my contract to use my subscription? So I'm back to subscription details and I will finish confirming this transaction. We'll wait for it to be completed. Any questions so far? Those of you following along, are we going too fast, too slow? Just right? Just right. All right. So we've added this as a consumer. Now you can see it here as a consumer. It's pretty cool. It will show you all the different events. It'll show you by consumer how much each contract has used from your total amount of link. And it'll also show you history of transactions. So let's go ahead and run request random words. We'll confirm this. And now we'll need to wait. And this one's going to take a little bit longer because remember, we have to wait for 3 blocks to be mined. So while we get our check mark here, that just means a request has been mined. But now we need to wait for that request to come back. If we come to our subscription, you can see it's pending. So now we'll need to wait and play some Jeopardy music. That's what happens in my mind every time I wait. Any questions while we wait? While we're waiting too, we can see our request ID is filled here, but our random words, it's going to be an array of 2 words. So we'll pick the first one. We don't have anything yet. So we've gotten our request, but we're waiting for that request to come back. And again, this does take a hot second. Cool. So we've completed this request. Our yellow dot turned into a green dot. Woohoo. Sometimes it turns into a red dot when there's a problem. Those are bad. So this request has gone through. You can see recent requests here. It shows, how much link it cost and everything. You can see now that up here we have this one consumer and the total spent for that consumer. If we head back to our contract and we look at our random words now, we can see a random number. And if we go to the second random number, you can see a different random number. These random numbers are huge. If you wanted to say like we were flipping a coin, heads, tails, you'd use a operator called modulo. It's the percent sign, which will essentially give you the remainder when you divide it by a number. So if, for example, we were wanting to do a coin flip, heads, tails, we would take this number, do modulo 2, and that would tell us whether it's even or odd. Our remainder would either be 0 or 1. And then you can pick, if it's 0, that's heads. If it's 1, it's tails, vice versa. But you have a random number here that you can now do what you want with. So like high level, this is Chainlink VRF and how to use it. You can get random numbers in a smart contract. Pretty cool, right? Numbers. Everybody's a big fan of numbers, right? The best. What can we actually do with this though? That's something a little more tangible and a little more interesting. I like this example. It's pretty straightforward and easy, but just getting a random number, I don't know, that's not really exciting to me personally. So let's take a look at an NFT. When it comes to NFTs, I always like to start with OpenZeppelin, just because OpenZeppelin is a fantastic resource and they have this wizard tool. I don't know if you've seen it before, but it's like, when I found it, it blew my mind. OpenZeppelin, they provide a set of like standard contracts that are like industry standard contracts. They're vetted, they've been reviewed. You can trust them, know that they're good and secure. if you go to products contracts, it'll tell you how to install them locally. If we're using Remix, we don't need to worry about this. We can go straight into the docs. And then here's the wizard. And this thing is awesome. So if you want like a regular ERC20 token, you can do it here. We're going to look at an NFT or an ERC721. What's crazy is you can just click and type in a couple things here, and it's going to update this contract for you. So, you know, you want to make your NFT and you want it mintable, and you want to like keep track of the IDs, and you want that URI storage so you can give it, you know, some images and metadata, and like, boom, we just copy and or open in Remix. And like, I don't know, I find this amazing that like there's this free resource where you can just click buttons and get like the skeleton for an NFT. So this is where I started for this project. Came here, got the skeleton, and I added some stuff to it. Again, within this GitHub, this VRF NFT is what we will be looking at. So just kind of keep that in mind. I've tried to put comments in here to explain it. So, you know, after the fact, if you come back, you can kind of read through and you'll know what everything is doing in here. If not, reach out to me on Twitter. But we've got that contract from GitHub. I just popped it into Remix. And we'll walk through this one too. I'll highlight the differences from the standard VRF contract that we had just a moment ago. First of all, you'll notice there's a lot more imports. Most of them that are new, I think all of them that are new, are from OpenZeppelin. These are essentially the contracts related to that NFT wizard. So we've got, the ERC721 wizard. We've got the basic ERC721 contract, as well as the one for URI storage. URI storage is going to let you have the information like traits, images, stuff like that on your NFT. It's the interesting stuff that shows up when you go to somewhere like OpenSea. Ownable. If you remember in the previous example here, we have this only owner, which works just fine. Ownable is like a super powered version of that from OpenZeppelin, where you can do things like transfer ownership and all sorts of stuff. We have counters. Essentially, that will allow us to say the first NFT that we meant is number 0, because computers like starting at 0 when they're counting. The second one is 1, 2, 3, just keeps track of what the ID of the NFT is, which is important when we take a look at randomness requests in just a moment. We have our two Chainlink interface and consumer contracts as well that we imported previously. We've got our contract name. We've got the types of, you know, it's going to be pulling in the different stuff from those contracts that we're importing: ERC721, storage, ownable, and consumer. We set up a variable counter, we say that we're going to be using counters, and we'll use that to keep track of the NFTs. We have our same VRF coordinator interface, same thing with the subscription ID. The address of the coordinator, again, this is dependent on what chain you're on. The hash for the gas lane, our callback gas limit. I did raise this in this example just to make sure I didn't run into any problems. If you were using a actual like production contract here, you'd want to go and make sure you took a look at the documentation and calculated out what the actual needs of your contract were and how much gas you were willing to spend. I just put this up at 200,000 just to make sure that we wouldn't run into problems in the demo. We have the number of confirmations again. In this case, I only want one random number, so I'm just setting that to 1. You could set it to more. We've got this massive array of IPFS URIs. What these are is these are the metadata that's going to be behind the NFT. So if we take a look, it's going to have all of the different pieces of the NFT, like the name, the description, an image. This image is also stored on IPFS, and the attributes. So this is how we will actually be creating a dynamic NFT. So we'll mint an NFT, and then it's going to change based on our randomness requests. So I don't know if anyone's ever watched any of my other presentations or anything, but I say something controversial sometimes, that I personally believe NFTs are boring because they don't do anything most of the time. And I'm a big fan of dynamic NFTs. And I will say NFTs that represent static images and stuff are fantastic at doing that, and they're very important. If I had gone and bought a Pablo Picasso painting, which many people say their 2-year-olds could do, and I came home one day and it had been replaced with a 2-year-old's drawing, I'd be pretty upset. So NFTs like that, that are static images, like I get it and they're important, but I feel like there's a lot of untapped potential. And so having NFTs that respond to the real world, that change, that evolve, I think that's really cool. This will kind of get into that a little bit as far as changing the growth of the flower as well as the color. So that's what those are, the IPFS URI. And just a time check, we've got about 20 minutes left, right?
Yes.
Okay, perfect. So we've got our array for random words as well as our request ID. The request ID is going to be very important in this contract because we're going to be mapping our request ID to the actual ID of the NFT so that you could have multiple NFTs asking for random values and it would kind of keep track of those. You can see that here with this mapping. We're mapping from the NFT ID from the request ID to the actual NFT ID. Then we have our counter to keep track of how many we've created. In our constructor, we do the same thing essentially that we did before, where we're setting up the coordinator in the subscription. We're also giving a name and a ID to our ERC 721 as well. We have SafeMint. This function comes straight from the contract wizard, SafeMint, except when we set up the token URI, I am forcing it to be the first value in that IPFS URI. So let's go back and look at that for a second. So in my mind, this is broken down into kind of 3 sections. We have the seed. We have 3 different colors of sprouts. And then we have 3 different colors of blooms. So 0 is the first one. Remember, computers always start counting at 0. They're weird. So 0 is the first one. It's going to be that seed. So when we mint this NFT, it's going to be a seed. And then we have a function called random grow. Now, previously, we had called this request random words. Here, we're calling it random grow because to me, that just makes sense because we want to grow our flower and we want it to be random. You could name this whatever you wanted. You could name it Bob. This is going to go and request that randomness, and it's also going to store the request ID for that randomness. We will then map that request ID to the token ID. So you'll notice it takes in a token ID when you request to grow. So if we mint an NFT, that'll be NFT 0, and then we'll grow it and we'll pass in that 0, and then it's going to map our request ID to that NFT so that later, when we actually get that response back, we can grow that specific NFT. We have some kind of helper functions here to determine things like the stage of the flower. This is important to know how to take the random number and what that means as far as which version of growth we're going to do, right? Are we going from a seed to a sprout? Or are we going from a sprout to blooms? Essentially, it's just going to look and see if we are a seed. If we're not a seed, we can just assume that we're a sprout because I've set this up so that blooms can just change color. And so we'll always end up in that blooms area if we're not a seed. We have our fulfill random words function. Now this one, you can't name differently, right? When we requested random words, we can name that differently. But on this one, this is what VRF is expecting you to have in your contract so that it can actually call into your contract with these random words. And you'll notice it passes in a request ID as well as those random words. So we take in the random words and we store them. We get our token ID based on the mapping of request ID to token ID. And then we generate a random color. So here we're taking in the random words. It's an array. We're taking the first one and we're using that modulo of 3. So basically we're saying, what's the remainder when I take this random number and divide it by 3? Based upon that remainder, it's either going to be 0, 1, or 2. based on that, we will then evolve the flower. We'll change the flower. So again, we'll call this evolve flower function. We're going to pass in that token ID and get, as well as the random color. So what this will do is it will change the color of the flower. But I feel like I've been looking at code for a long time. Let's deploy this and get going with actually seeing it on OpenSea first as a seed and setting it up before we take a look at this evolve flower code. So again, if we want to deploy this, we'll come in here to deploy and run. I'll hit again on the auto compile, or you'll need to compile it manually. We'll need to make sure that we pick injected Web3, as well as the correct contract. You'll notice this one has a lot more contracts. That's because of all the different contracts that we're importing. And then we'll need our subscription ID. We can use the same subscription that we created earlier. Your ID probably will be different than mine. I would hope it's different than mine. We'll deploy our contract and confirm while we're waiting for this confirmation to come back. Any questions? My demo abilities are on par with my presentation abilities, apparently. All right. So we've got our contract actually deployed now. There's a couple of things we're going to need to do. First, we're going to need to let the subscription know about this contract. So we'll grab our contract address. We'll head back to our subscription and we'll add a new consumer. Pop in the address, add consumer, approve this one, wait for this to come back. While we're waiting, we can also mint an NFT. So we'll copy, this is my wallet address. You'll want to copy your address. You can either copy it here from that account. You could pop open your wallet, copy it from here. Those two should be the same thing. We'll open up our contract and we'll safe mint to our address. So this will actually mint an NFT to our address, to our wallet. Confirm this. While we're waiting on that to confirm, we'll kind of go back over here to subscription. We'll see our consumer's been added. Sweet. You can see both of the consumers are here now, except for our new NFT contract hasn't used anything yet. Okay, we'll head back here. We've minted an NFT to ourselves. So how can we see this NFT? Well, we can look here and see things like the owner of token ID 0. That's going to be the one we just minted because it's the first NFT token. Hey, that's me. We can look and see what the token URI is. That's going to be that URL from IPFS. We can see it's a seed. But these are all kind of, I feel like these are like the random numbers where we're just seeing a number. Let's actually see what did we do. And I will say OpenSea sometimes is a little slow, but we'll take our contract address. We'll copy that. We'll head on over to testnets.opensea.io. You have to remember, if you're on one of the testnets that OpenSea supports, like Rinkeby, then you need to go to the testnets version of OpenSea. If you go to the regular OpenSea, you won't see your NFT. There's like a poem in the making there. We paste in our address and you'll see the collection shows up. It's DNFTs. That's what I named this NFT. If we come back here to the constructor, you'll see I named these NFTs the DNFTs, dynamic NFTs. And you can see here, it's a seed. Huzzah! It has the property of a seed. And this other property of color is unknown currently. Sweet. So we actually have an NFT that we own. It's owned by me. It even knows that right there on OpenSea. So at this point, we want to randomly grow our NFT. So we will use the random grow function here, and we will confirm this. So what this will do is it will go and make that request to our subscription. We should see here in just a moment, once this is confirmed, still pending. Once this gets confirmed, we should see it show up in our subscription. So while we're waiting on that to go through Rinkeby, there it is. Now we should see in our subscription, if we refresh this page, hey, we've got this pending transaction, right? So we're waiting on that random number to actually be generated, confirmed, and sent back to our contract. So our seed's still a seed until that happens. But when that happens, what actually happens within our contract? So I think previously we left off at fulfill random words, and then we were going to talk about evolve flower. So it takes in the token ID and that color profile. Remember, that's going to be 0, 1, or 2. Based on the random number that comes back, we're going to say what's the remainder when we divide it by 3 or modulo 3. We will then get the current stage of the flower using this flower stage function. Essentially what that's going to do, if you remember, I broke it down into the seed, the sprouts, and the blooms. If it's a seed, our new value is just going to be that color profile. If it's anything else, it's going to be that color profile plus 3. And then we'll set our new URI equal to that new value. So what does that mean? If we go back up to our array. So if it's the first one, we're going to set it to, it's 0, 1, or 2. I add 1 to it just because we have to account for this first entry, right? So it's really 1, 2, or 3. So this is the 0 entry in this array. So randomly, it's going to be either 1, 2, or 3. If it's a sprout already, we're going to add 3 more to that, right? So we have 1, 2, or 3 plus 3. So that's going to be 4, 5, or 6. So it will then, like, once it gets to the blooms, it will randomly change colors within the blooms each time we call this random grow. But I feel like I've been talking long enough that this should be done by now, and it is. So our random number has come back, and that means our seed should have sprouted. Real quick in the chat, it's either going to be blue, purple, or yellow. Anybody want to guess what color it is? I can hear Danny, he's saying always blue, always blue.
Let's see.
Okay, we've got blue and yellow. We'll see. So the way OpenSea works with dynamic NFTs, you'll need to refresh the metadata. They cache the metadata of the NFT. So you'll need to click that refresh button. Essentially what that does is it goes back out to the blockchain and says, hey, what's going on with this NFT? And then when you refresh the page, hey, it's blue. So our seed grew into a blue seedling. Pretty cool, right? We had no idea what it was going to be. This is the same NFT. Like if you go down here and look at the transaction history, you can see like it was just minted and that's the only like transfer that's happened. Pretty cool. If we go and we grow it again, we'll get a full bloom with a random color. But that is, I don't know, just kind of a one way you can apply VRF randomness when it comes to NFTs. You could do a similar thing with getting randomness for various traits. You could use that randomness in a lottery. Essentially, the sky's the limit when it comes to randomness. I would love to answer any questions that you have while we wait for this one to come back and see what color we get into for the full blooms. So what color? All right. Well, let's see what we turned into. Are we sticking with blue? What do we think? Could be blue. Oh, it went purple. So if I did it again, it would stay as these blooms, but it would just change color. I don't know. I think it's pretty fun. I think it's pretty cool. And I don't know. I hope that you all enjoyed this, learned something.
Yeah, thank you so much for that amazing presentation and demo. I believe you kind of just everything spot on there throughout the entire presentation. But of course, do you have anything left to say? Any conclusion?
No, in the GitHub repo, I don't know if you mind sharing again the link to that. There's everything from this presentation, and yeah, Chainlink documentation is there. The Discord's there to help you as well. If you want to join the Discord, if you have questions, we have the Academy as well as my Twitter. So yeah.
Amazing. Yeah. And I shared his Twitter there here earlier in the call. I just shared our Twitter again. But again, Richard, thank you so much for another amazing presentation and kind of just to keep it on everyone's plate. Oh, I think we did just get a question in the chat.
OpenSea testnets is not working, what tool do you use to check the metadata of the NFT without having to verify the contract on Mumbai? This is a very good question. I should probably make a blog post or a video about this. I have built a tool myself, just using like Ethers.js. So I would share it, but I don't want like the URL to get used because like it uses my own personal Alchemy RPC endpoint and I'll run out. But essentially what it does is it just pulls that data for the NFT into a browser and like renders out the image and then like just displays the data. But yes, that is a pain when OpenSea is not working. I feel that pain. So Carlos, I don't know if you want to like hit me up on Twitter or whatever, but I can share with you the code for that. Actually, let me see if I can just pop that into the demos. I can get you a link to it. Hold on one second. I'll have to go in and change it, but I will change it to be publicly viewable here in just a second, Carlos. Within
Great.
5 minutes of this being done.
Perfect. We're going to wrap up then. Just as I mentioned before, the next event, part number 4 of the 8-part Chainlink Educate series is next week on the 5th of July. There's a registration link right there. Outside of that, please, as always, do continue to reach out if any questions do come up in the meantime. But everyone, have a great rest of your day, evening, morning, wherever you may be located. And once again, thank you, Richard.
Yeah, thanks.